So in this example, we need to factor the greatest common factor out of the expression that has two terms. Our first term is going to go in the box on the left. So we have 15r to the fourth plus 9r. My GCF, the greatest common factor, is going to go on the left side. So I have a 15 and a 9. The greatest common factor of 15 and 9 is 3. And then I have r to the fourth and r to the first. So there's an invisible power of 1 we don't see. The number of r's that's in common is 1r. So 3r to the first goes on the outside. And then we're going to work backwards. So when we multiplied 3r by something here, we got 15r to the fourth as our answer. So we have 5r to the third left over. And then when we factored out 3r, we have a 3 left over here. So my answer in factored form for the area of this rectangle is going to be 3r multiplied by 5r to the third plus 3. And then that's it. In this example, I also have two terms, so I'm going to write them in my box. I have negative 2x to the fifth, 6xy squared, that's negative. So first, I want to think about what is my greatest common factor. Both negative 2 and negative 6 are negative, so I'm going to take out a negative number. The greatest common factor of 2 and 6 is 2. The greatest common factor of x to the fifth and x is going to be just x. And only the second term has y squared, so I don't have any y's in common. So negative 2x is my GCF, and then I'm going to work backwards. So I multiplied negative 2x by something here to get negative 2x to the fifth. So this right here has to be x to the fourth. And then I multiplied negative 2x by 3y squared in order to get negative 6xy squared. So another way to write the area of the rectangle in factored form is going to be negative 2x multiplied by x to the fourth plus 3y squared. And again, remember these are just two equivalent expressions. They're two different ways of writing the area of the same rectangle. On the left side, we added up the two little areas, and on the right side, we're writing it as a product of length times width. Okay, so in this example, we have three terms. So I'm going to place each one in a separate box. I'm going to look for the GCF. I have 10, 8, and 4, so the greatest common factor for 10, 8, and 4 is 2. I have r to the fifth, r to the fourth, and r to the third. My lowest exponent is 3, so that's how many I have in common. Right here, I need 5r squared. I need 4r. And here, I need a 2. And remember, a really quick way to check is to multiply it out and then double check that these are our answers. So in factored form, the area of this rectangle is going to be 2r to the third times 5r squared plus 4r plus 2. And then that's it. Okay, so this is going to be our last example for the GCF factoring. I have three terms. I'm going to place each one in a separate box. And the first thing I'm going to do is going to look for the GCF, the greatest common factor. My leading term here is negative, so I'm going to take out a negative number. What do 10, 40, and 100 have in common? What's the greatest common factor? It's going to be 10. And then I have x squared, x to the first power, x to the first power, so I only have one x that's in common. And then I have y to the seventh in common because this term has 10 y's, this term has 8 y's, and this term has 7 y's. And then we're going to work backwards. So I need xy to the third. Here I need negative 4y. And here I need positive 10, and then that's it. So in factored form, this trinomial is going to be negative 10xy to the seventh, factored on the outside, xy to the third minus 4y plus 10. And that's how you can factor using the box method.